Good afternoon. In the last class, we have studied what is multiprocessing. We have studied what is CPU, scheduling, and so on. Right? Do you remember? In this class, I'll be introducing to you a very new concept called as threads. What are threads? What are multi-thread models? What are the issues associated with threading? Okay. So in this class, we will be studying about a very new interesting concept called as threads. Okay. Along with that, we'll be studying multi-threadings and threading problems associated with threadings. The last class I gave you an introduction to CPU scheduling and what are the different kinds of CPU scheduling algorithms. So what is a thread? A thread is the smallest unit of execution within a process. So you have a process, let us consider this to be a process. You have a process in that a small unit of processes, small units of processes is called as threads. So that one part can be completed. If you have studied Java, do you have Java in your syllabus? No, when you start studying Java, you will find that Java uses threading concepts very effectively. We have multi-threading and we have different threads. Why do we need to do it in terms of threads is something that we need to look into as we go on. But to begin with, the definition of threads is that a thread is the smallest unit of a process, right? It represents a single sequence of instructions that a CPU can execute independently. That means that you are calculating one thing which does not depend upon the others. Okay, process is there, a big process is there, a process will have smaller units of thread. So these threads are independent units. It can act without the support of any other unit. That is called as a thread. Okay. So a process, program, and threads, all these three things are different. Don't consider all these things to be same. Okay. So a process has multiple threads. Thread is the smallest unit of that particular program. Can be a single statement or a single set of statements, right? This single thread of control allows the process to perform only one task at a time. The user cannot simultaneously type characters and run the spell. For example, you have a software which is going to check the spellings. Okay, so only after you have typed, the spelling can be checked, right? Otherwise, you get a lot of errors. Is that clear for you? This is an example of how we can create threads. So this is a block diagram which gives you a more clear picture view of what would be a thread. So you have a program. So a program, you know, is already, a program is a set of instructions. Okay. You have a hard disk where you store this memory or the storage memory is there that we'll be dealing with in detail. These instructions will initiate a process. There will be a group of processes. And these processes will be abstract in the sense that there will be only one process that does not depend upon the others. And then what we do that we use the random access memory for the storage of temporary variables or cache memory. Okay, so this will create multiple processes. These are processes, these things, these threads which you see. Sorry, these are threads. These multi-processes will be having, each process will be having multiple threads. These threads are different independent units that can operate without the support of any other thread. So you have multiple threads here, and this will connect to different threads. Threads will be having different priorities. Based on the thread priority, we can select the thread whichever is having higher priority, and this will be executed, and finally you will get this to be connected to the operating system, and you have the processor which is doing all these process in at a single point of time. Okay, this is called as multi-process multi-threading. Okay, so if at all you are asked to write for a 2-mark question or something, define thread, you can write a thread is a single flow of execution and considered to be the basic unit of CPU utilization. So depending upon the number of threads that is utilized is what we calculate the CPU utilization in general in total. Okay. So what are the advantages of threading? These are all theoretical academic based questions. You can write down these points. You will have more points under notes which I have shared, which you can use for your answers. But these are the basic points which can be considered when you have threading. You have a faster context switching than the processing. Instead of switching the entire multiple processes, threading can make it much more easier. More effective or efficient utilization of faster context switching than processes. More effectively CPU is utilized, efficient utilization of CPU, resource sharing among other threads. Okay, enhanced responsiveness in applications. Do you know what is meant by responsiveness? The time to an application to respond. Okay, so there are more chances that your system can respond earlier to your request. The time taken or the waiting time or the idle time will be less, somewhat similar to what you call it as CPU utilization. So how effectively you are using the processor. For these, all these ideas are generated or all these things are created just for the sake of understanding that you have effective utilization of resources. Okay, you understand, all of you? What are multi-thread models and why do we need threading in general? We have two important points that you have to understand. As the number of duties increases, the number of processes also increases. This is a simple diagrammatic representation of this for single threads, and these are multiple threads. You have these are the basic operations that we require, and these are the registers, and these are the basic resources that we have, and we are going to effectively utilize these resources. So here, so what happens is that we have we have to effectively use the memory that is available within our system, right? We have to have a main memory, a cache memory, and so on. So this virtual memory is a temporary memory where you keep storing information. May reach an inefficient state of memory, at least one with a very low efficiency. So when you have more number of processes going on or more duties to be done by the processor, the effective utilization of memory becomes lesser and it becomes very competitive to use that. So when we have multi-threading, what happens is that the usage of memory is being effectively done, right? Yes or no? You are able to understand, all of you? By increasing the number of processes, the number of objects that compete for the computer resource also increases. This could lead to an undesirable state of system in which many processes cannot complete their duty because they do not get the chance to use the resource needed. Suppose you wanted to have a resource, you have only one printer, you have 10 things to be done. If the same printer can be used for printing two documents at the same time, you effectively use the printer, right? Yes or no? But we cannot do that in case of printing. I'm giving you a simple example. But in other kinds of processes, we can do multi-threading, which reduces the. There might be so many things that is not used for this particular process, but used for another thread, so that we have processes completing much more faster, and the resources, other resources also being effectively used. You may need to have, you may get questions like, why do we need to have multi-thread models, or what are the advantages of having multi-thread models? So for all these things, your answers are these. So we'll see an overview of what is multi-threading and how it works. So multi-threading operating system is the one that is capable of handling processes and threads at the same time, in which every process is allowed to generate more than one thread. So if an operating system has the ability to generate multiple threads for the processes which can be done at the same time, we have some advantages, and that's what is called as multi-threading, and how we are going to create multi-threaded models. What is an application? Next question is, what do you mean by an application? Application means there is separate processes with several threads which are controlled. We'll be dealing with applications in detail. We'll study how APIs work and so on. Okay. Now I've given you two examples here. One is that a web browser may need multiple threads. On one part it will be downloading something, and one thread may display images or text while the other thread connects to the network and so on. There will be two multiple threads. So you have multiple processes going on. One is a network connection being taken care of. Other one is the image being displayed in the user end. Similarly, for a word processor, there might be different kinds of ways through which graphics is being displayed, and there will be another thread which responds for the keystrokes from the user. You are typing, as well as there is an image that is being downloaded into your screen. Okay, these are the examples. So what are the different types of multi-threaded models? These are, you have three different types. One is called as many-to-one model, the other one is called as one-to-one model, and the next one is many-to-many model. Okay. So let's see what is a many-to-one model threads. So multiple threads are mapped to a single kernel thread. This is a single kernel thread, and you divide it into multiple threads. Okay. Blocking one thread blocks all these threads. In many-to-one model, if you block one thread, all threads are blocked. Thread management is done by thread library in user space, so it is efficient. Okay. There is an example for this. In Sun Solaris, you have something called as green threads, which is adopted in this first kind of versions. Later on, there is changes. Okay. So many-to-one model. The next model, we have a single kernel for each thread. So there is no interference from the other one, and every kernel thread is being connected to a user thread. In one-to-one model, each user thread is connected to a kernel thread. It provides more concurrency than many-to-one model by allowing another thread to run when the thread makes a blocking system call. It also allows multiple threads to run in parallel on multiple or multi-processors. The only drawback of this model is that creating a user thread requires creating a corresponding kernel thread because each one is connected to one kernel thread. Okay. The next one is called as many-to-many model. So if you have understood many-to-one or one-to-one, it's very easy for you to understand many-to-many model. So instead of one, you have multiple kernels and multiple distinct. The main drawback of one-to-one was we need to create a single thread for each kernel. Here it is not required. So many-to-many model, like what we have in our diagram, we have a single thread and it can use any. The main drawback we had with one-to-one was that we need to create a thread for each and every kernel thread for each and every thread. Here, what we can do is that we can share these resources. That's what is many-to-many, just to avoid the drawbacks of one-to-one. Okay. So the number of kernel threads may be specific to either a particular application or a particular machine. An application may be allotted more kernel threads on the multiprocessor than on a single processor. Whereas the many-to-one model allows developer to create as many user threads as wished, it does not result in true concurrency because the kernel can schedule only one thread at a time. Is that clear? So the one-to-one model allows greater concurrency, but the drawback was that for each thing we need one kernel threads to be created, right? But the developer has to be careful not to create too many threads within the application. So multi-thread models, we have three types: many-to-one, okay, one-to-one, and many-to-many models. So these are the problems that might arise while we create threads. First thing is the context switching, synchronization, deadlocks, starvation, and scalability. So context switching means switch between threads occur overhead. Okay. So when one thread is over, you need to complete or you need to switch on to the other thread. One thread could be terminated in another round and so on. So what happens is that you need to have a shifting system or switching system from one thread to other. So these threads share resources, making it more efficient than process switching. Synchronization. It is very difficult to synchronize. When we have multiple processes and each process has multiple threads. And so what happens is that you may need to synchronize this. Threads accessing shared resources may cause race conditions. What is race conditions? I'll teach you in the next class while I'm talking to you about process synchronization. The next class will deal with what is meant by process synchronization and what are the methods and algorithms that is used to synchronize processes. So what is a race condition? Mutex, semaphores, and locks that are used for synchronizations. These are different synchronization techniques. What are these techniques and how these are implemented? We'll see the next class. What is a deadlock? When a situation arises that the threads are there and it cannot be released, and there can be a situation where the processor cannot be utilized. A similar condition when you find when you say that your system is stuck, no? Many times you might have noticed. It's a deadlock when there are so many processors and the processor is not able to process any of these processes. These conditions are called as deadlocks. Okay. Starvation. Some threads may not get CPU enough time. No, some threads will be very hungry. That's why it is called as starvation. No food is provided for these threads. The threads are waiting for the process, unable to get its due share because of the engagement with CPU. Threads improve the performance but also increase the complex scalability. You make these things much more complex, right? Instead of being very easy. When there is only one process and a single thread, there is no work to be done. When you have threads, you need to make more work. You need to divide the CPU time. You need to work on threading, process, creating threads, and so on. This context switching, and so on. So your operating system must be very efficient to manage threads. So with this, we'll wind up today's session. In today's session, what we have seen, we have understood what is thread, right? We have defined what is thread. And then what we have seen, what are multi-threads, right? What are the advantages of threading? What could be the disadvantages of threading? Of course, obviously it is going to become complex, right? So you can use your common sense sometimes to give answers if you are not able to remember or recollect what you have studied in your exams. Say, suppose I have not taught you what is disadvantage or what is a problem that might occur while threading. You can use your common sense and say that it becomes more complex, right? Naturally and obviously. So, in the examination point of view, keep these points in mind. Even if you don't know certain answers, you can create your answers with the help of your common sense. Okay? So, rethink on that. And when you get a question, do not abruptly feel that you don't know anything about it. You read the question more than once. There are possibilities that you can answer it. So here, one example I told you right now, disadvantages of threading, it becomes complex. Okay. What are the advantages of multi-threading? I've already shown and we have discussed it, right? So multi-threading models, we have seen what is meant by multi-threading models and why do we need multi-threading models and why is it essential? Although it has some disadvantages, it is essential. Right? Same way. The next point, what we discussed three types of multi-threading models: many-to-one, one-to-one, and many-to-many types. So you need to understand what are these three different types of multi-threading models and what are the advantages and disadvantages of each of these models. Okay. And in the final slide, we have discussed the issues that might arise while we create threads. So this is a oral summary of what we have dealt with so far. Is there any questions from your side? Any things that you did not understand you want me to repeat again? Of course, you can be very frank with me. I enjoy interaction, so you can just ask me anything if you want. So thank you all, thank you very much.